Let the hydrocarbons in Prince William Sound talk. 30 years of environmental monitoring through the Prince William Sound RCAC's LTEMP program, which is the long-term environmental monitoring program. So I'm going to be using that acronym quite a bit. As Danielle said, my name is Morgan and I'm based here in Anchorage, and Danielle and I put this presentation together. Great. First, we're going to start off with an introduction of just what this monitoring program is, how it's conducted, what we're actually monitoring, what it has experienced, what do the results say, and where it's going. So sort of a past, present, future outlook. And in case the environmental chemistry bores you the slightest bit, there's this little otter tracker up here to let you know how much longer it's going to be before the next talk and hors d'oeuvres. Great. First, we have the goals of LTEMP. So monitor the impacts from oil transportation activities in Prince William Sound and in the greater Gulf of Alaska at specific sites. So we're unfortunately not able to measure things everywhere, but I'll pop up where we do measure things. Identify the sources of these hydrocarbons. That's what we're actually monitoring, because that's not always straightforward. You find them, but you don't know where they came from. The third goal of LTEMP is to provide recommendations and future response and mitigation measures, and to continually improve the program to make sure it stays relevant. And this program is based under the Oil Pollution Act of 1990, the same thing that established the RCAC committee, and it meets the requirements that RCAC has with LESCA that were established in the beginning. These are some throwback pictures. I'm sure there's some familiar faces, and we'll explain exactly what's happening in each one of these pictures as we move through the presentation. Great. So to orient you guys first spatially, here we're in Port Valdez, and this is really the core of the program these days. And we collect 3 different kinds of samples. We collect sediments from outside the terminal. We collect blue mussels from a few different sites around the terminal and in the port. And we also deploy passive sampling devices, which collect compounds from the water itself at a few sites in Port Valdez. So this is the sediment sampling site that's right outside the Valdez Marine Terminal. And this lines up underneath the water here. There's the outflow from the ballast water treatment facility. So this is where we would expect most of the hydrocarbons related to the terminal to come out. So this is really our shining star station of what hydrocarbons might be entering the system from the terminal. And here on the other side of Port Valdez, Danielle is showing us the mussel bed that we collect mussels from at Gold Creek. So why do we collect blue mussels and sediments? That's a great question. Thank you for asking. Mussels are an indicator species for these kind of hydrocarbon monitoring programs all over the world. They're caging mussels in different seas next to oil rigs. And that's because these guys do a good job of sampling the water for us. They collect the compounds that are in there, and they're not super good at metabolizing and getting rid of these compounds, so they accumulate them. They're also important ecologically. There's lots of critters that like to eat mussels as well as people, and they are very common in Prince William Sound. So we're able to use a native species that's used to growing there, sampled all over the sound in the North Gulf of Alaska. So it's kind of like a genius little critter for sampling these kind of things. Great. Now I'm going to expand all the way across Prince William Sound, kind of in a swath from Valdez to the south and to the west. We have sampling blue mussel locations in Night Island and all the way across the North Gulf Coast of Alaska. And for those of you who are familiar with this particular map, you'll see that a lot of our stations overlap with previously oiled Exxon Valdez stations. So the way that this program is designed is to look at residual pollution that might have come from the Exxon Valdez oil spill, to look at sites that were never oiled, like these ones over here on the eastern side of Prince William Sound, and also to monitor the terminal operations in Port Valdez and along the shipping route and in anchorage areas. So that's a little bit about how the sampling sites were developed. And this is how it's actually done. We have our historic wooden vessel, trying to get Dave Jenkins' nod here. The research vessel Auklet has been kind of the main platform for LTEMP sampling for most of its history. So here we have the Auklet doing some sampling on a beautiful spring day. We have another a member of the scientific advisory committee, Sarah Allen, who helped develop the passive sampling aspect of this program. This is just kind of keep you guys entertained before all the chemistry comes up. Some of the sampling happens by helicopter. So here's Danielle and Austin sampling mussels in Sheep Bay earlier this year by helicopter. These mussels are then transported to the lab in a frozen state where they're analyzed, but you have to collect them first. And then here's some sampling by float plane that occurred in Ayalik Bay a few years ago. I should say, I don't think I mentioned it in the original slide, but the Port Valdez sites are sampled on an annual basis. And then we fly out or take the boat out to these more remote locations outside of Port Valdez now on a 5-year basis. And this gives us a really good idea of what's happening close to home at the terminal, as well as across the whole swath. Okay, but what does it mean to actually sample these things? So this is the sediment sampling component. We have some LTEMP gurus here, Jim Payne and Bill Driscoll, who are sampling sediments from the modified Von Veen grab. And this is a contraption that's lowered into the water. It is sort of, when it lands on the bottom, it does sort of like a giant dinosaur jaw grab of the sediment and brings it up relatively undisturbed. And then we're able to take the top layer of the sediment here using very clean utensils and get the most recent picture of what chemicals are associated with these sediments, and then send them off to the lab in a very clean jar. Oh yes, a jumpy video. So this is the Von Veen grab being reeled up. Looks like we're at Gold Creek here and looking down Valdez Arm.
Surface. Stop. No trip.
So there we go. That's the contraption. The dinosaur jaws that I explained have not closed on. So even though we're using modern technology, it's not always super straightforward sometimes to get these samples. So that'll have to be lowered again. And here is the Pacific blue mussel sampling. So we have a few of our LTEMP samplers out on the mussel beds. These mussel beds have been used for decades now for these specific purposes. And 30 mussels are put into a aluminum foil bag wrapped up. And then that process was repeated 3 times. So we run triplicates for each one of these samples, and that gives us an idea of the variability in compounds over the sampling site. And then those are shipped off to the lab for analysis. And the last thing that we look at is the concentrations that are in the water. And here we use passive sampling devices, which are laboratory engineered plastic strips that are deployed for a month-long period. So they're put out right before, a month before the sampling of the other things, and they're put in an area that will be submerged in water for that entire month, but relatively close to the blue mussel sites. And these guys manage to absorb the compounds in the water that would be most available to the organisms that live in that water, like the fish or the zooplankton. And these guys actually have a much greater ability to detect concentrations that are smaller than what we see in the sediments and in the blue mussels. So they sort of give us a superpower to see really low levels of hydrocarbons. And then we send them off to a lab for analysis. Great. Now we are on the numbers section. This is just a quick review of what it looks like to have a long-term database or a long-term study like this. So we've got 30 years of data. And I can tell you personally, that means that we have a database that has 238,000 individual measurements. So it's a pretty huge database at this point. There's been about 13 plus or minus experts, including the Scientific Advisory Committee, which has been heavily involved in LTEMP from the very beginning, and some star names on this list as well. And these people really have a good handle of what's happening with petroleum chemistry in Prince William Sound. And I think they've really led the project in a good direction. There's been about 16 different iterations of an analysis of this data set at this point, and then a few different versions of those analysis. So people have been looking at this quite a bit. There's been 5 analytical laboratories involved. The ones that we use most recently are based off the East Coast in some really professional petroleum chemistry labs, as well as the Oregon State Food Security and Environmental Sustainability Lab, which helps us with our passive samplers. 3 different transportation. We're talking boats, float planes, helicopters. So it's a pretty exciting study. And then I already made my call out for the research vessel Auklet, who's played a large part in the LTEMP study. And for every single sediment or mussel sample that we analyze, we get 160 results back. So we're analyzing 160 different compounds in these organisms. So that gives us a lot of information about what they're being exposed to, what the hydrocarbons are coming from, what happened to those hydrocarbons before they ended up in the sediment. So there's really a lot of different stories in this database. So you can imagine how hard it is to keep this presentation to just 25 minutes. But we write a lot of reports, so feel free to check out those reports. Okay, now we've made it to the next section about what LTEMP weathers. So we've got Exxon Valdez in '89, we've got the Oil Pollution Act and the formation of the RCAC in '90, and then LTEMP started in '93, though of course it needed to be planned and thought of before that. So people were hustling. 5 years later was the first data analysis. And LTEMP went through its first sort of major reduction in sampling, where we moved to this sampling every 5 years and sampling on an annual basis in 2010. In 2016, we added the passive sampling devices. In 2020, the LTEMP findings were analyzed in a new way, and we included some transcriptomics, which is small biological changes that are happening in the blue mussels, and the LTEMP data was really influential in understanding the responses. And now we're celebrating 30 years. But what else has been happening during this time? What is like the context of this? So we have decreasing oil throughput in the pipeline. That means that there's less output from the ballast water treatment facility, which is where we do a lot of our sediment sampling. We also have some changes in the terminal or in the tankers. We have fully phased out the single hull tankers. Now we're doing double, and segregated ballast water tanks, which means that there should be less hydrocarbons entering the system at any one point, or possibly being released from the ballast water treatment facility. The treatment facility has also been upgraded, so that changes what is coming out of it. But there are also terminal spills that we see in our LTEMP data set. These ones are pretty notable in our recent memory. There's been some diesel spills that we've detected at Gold Creek, for example, so that throws something else in the mix. And then when we look at the Prince William Sound environment as a whole, we have regional warming, we have freshening from increased meltwater, and this all changes the way that hydrocarbons interact in our environment, how they themselves weather, and how organisms would respond to it. And that continues for the cold periods that are identified and the marine heat waves. So there's really a lot of things going around in the background which can affect, a measurement of a hydrocarbon. Ooh, sorry, that was a busy one, eh? Great. So what does the data actually tell us? So here I've plotted the sediment hydrocarbon data for a specific small group of hydrocarbons. I said we measure 160 things, but here I'm just putting a few of them on the y-axis, the ones that are believed to be most important for the toxicity to organisms. And then they're in nanograms per gram, which is part per million. So pretty small units that we're talking about here. And then the different colors that you see are the two different stations. The purple is the terminal in Port Valdez, and the gold is Gold Creek. Tried to make some things intuitive. So we see that in the beginning, there was quite a bit of variation, and that this calmed down, looks about 2006, and for the last few years. And when we get to this level, it's actually becoming pretty difficult for the chemistry itself to resolve. We're getting to issues with even detecting these compounds. So the changes that we see here are likely not biologically significant, and we probably need to, be cautious about any interpretation. But we see low levels. And this is the hydrocarbon data from the blue mussels. We're in the same hydrocarbon grouping that I mentioned earlier. We see a lot of variability in the first decades of LTEMP, and then lately, we see pretty strong responses to our known spill events in the blue mussels. So these guys tell a different story than the sediments, which is why it's important that we're looking at different things. They respond quite quickly to the spill events, and then they're able to process, and the oil is no longer present in these mussel beds. Great, but why are we talking about hydrocarbons? Hydrocarbons are known to be toxic to aquatic life. The specific group that ecotoxicologists like me focus on is the polycyclic aromatic hydrocarbons, or PAHs. And they can cause developmental effects, cancer, reproductive growth and impairment, changes in swimming ability, and death at higher concentrations. And I'm sure some of you have seen this work previously. But a lot of the recent work on PAHs in the aquatic environment has focused on their effects at low concentrations on the early life stages of fish. And these are fish that we're familiar with. So here we have pink salmon that has been unexposed as an egg, and those that have been exposed. And we find that the heart is one of the pathways that's affected, not the only one, but one of them. And that means that during development, we see really strange deformities and issues with the fish as it grows. So we have lots of fluid around the yolk sac. We see that things aren't able to function as they should. And these are at relatively low concentrations of crude oil. Same thing in herring in this picture. This is the one that didn't have any oil in its water. And then this guy is pretty funky. It's got deformities of its tail and of its face. And this is work that's come out in the Northwest Fisheries Science Center. I have similar work that I've done in the past, focusing on Arctic cod, which unfortunately is not a Prince William Sound species, but we find it in the Bering Sea and all around the Arctic. So here's one that's been reared in clean water. And then if you put just a tiny bit of oil in the water, 0.2 parts per billion of these toxic compounds that I talked about. These guys are the same age. They aren't able to grow. They have really strange, gross deformities of their face, of their eyes, and these guys actually die of starvation. So this work is pretty important for understanding the levels that we find in the environment, but at the same time, it's sort of tough to translate that back and forth between the lab. So that's what we're working on now. So if we take what we know from the lab and what we see in the environment, what do these hydrocarbon levels mean? So what we see recently in the sediments is that there's low risk for adverse effects from these hydrocarbons at these specific stations that we've monitored. And they're, 1% of the EPA's chronic toxicity benchmark. This is a slow clicker. Intertidal mussels, similar story. So in the absence of a spill event, we do see low levels of hydrocarbons that are unlikely to elicit adverse effects in these guys, or if they are consumed. And lastly, the passive sampling devices, which sample, again, the water and the compounds that would most likely come in contact with organisms in the water, we see low risk. Okay, moving on to the next aim of LTEMP. Remember, there was only 4. No, just kidding. How do we figure out where these hydrocarbons are coming from? So the first technique we use is by comparing individual patterns that we see in the chemistry data. So if I were to plot hydrocarbons that I sampled in the sediments and group them, and then I see that there is a rainbow in the grouping, that tells me that these compounds are of petrogenic origin, which means that they are crude oil. So that can be crude oil, Alaska North Slope crude oil, it can be crude oil from a natural seep, or it can be crude oil-like compounds that would come out of coal seeps or peat in the area. So it doesn't give you all the answers. If I see that it is a ski slope and you can ski down it, then it is of pyrogenic origin, which means flames. And so that's things like exhaust, that is creosote, that is forest fires. Some of that might not be from the exact local area and may have been transported, but these are some of the tools that we use to interpret the data. The second method is using biomarkers, and these are long-lasting petroleum identification compounds. Not something that's easy to interpret on an ecotoxicological scale, but really important for hydrocarbon forensics and fingerprinting. So this is a specific group of compounds, terpenes, hopenes, and sterines. And what we do is we take an individual sample and plot them up and then compare them to known sources. So the different colored lines I have here are things like Alaska North Slope crude in purple. I have the terminal spill in pink and the ballast water effluent. So these are specific to the terminal, specific to this exact kind of oil. And we see, wow, yeah, there's pretty good agreement there. You can also use really advanced statistics, but I didn't want to bore you with that. So here we go. What do our hydrocarbons tell us? At the Alyeska Marine Terminal, for most of the recent history of LTEMP, we see a really strong petrogenic signal that's related to Alaska North Slope crude. Great, that's pretty easy. At Gold Creek, we see something a bit different. We see this petrogenic signal, so from crude oil, from natural seeps, from sediments around, but we also see evidence of exhaust, of creosote, of some other source. So it's mixed. The hydrocarbons also change over time, they weather. So there's a lot of different techniques that you have to use to untie these things. But this is essentially what the LTEMP data set has been telling us for the last few years. Ooh, the future section. Long-term environmental monitoring is part of Prince William Sound RCAC's mission of promoting environmentally safe operations. To have this kind of baseline data is really unique, and this will allow us to detect change, injury, recovery in the event of a spill or other environmental change. So like I said, this is a really rich data set, and I'm just telling you a few stories out of this. Being able to pull other information for other studies and other questions is totally possible. And the fact that it's collected by RCAC and maintained gives it sort of a secret weapon in its strength and independence from industry research, for example. But where are we going? So one of the breakthroughs that we've had in the last week actually has been to archive this data in a really public place in the Alaska Ocean Observing Network. So they have a new updated data set, and this will allow other interested parties, researchers, scientists, school children to stumble upon this amazing data set. So hopefully we'll get some hits from that. It's annually revised to both preserve LTEMP's aims, make sure we're still on track there, and to modernize it together with SAC, the Scientific Advisory Committee, contractors like myself, and with RCAC staff. It spins off into different complementary projects, such as the transcriptomics that I talked about in blue mussels that came out of the 2020 oil spill, and the presentation that we saw last year at Science Night with oxygenated PAHs coming out of the ballast water treatment facility. So these questions are really based in the LTEMP data set, and then they've been expanded into these other side projects. And then it will continue. So as long as oil flows through the pipeline and the Valdez Marine Terminal exists, LTEMP will too. And now there's probably no time for questions, right? Great. Any questions?
If anyone online has questions, please feel free to put them in the chat.
Thanks. On the database on AOOS, is it the full database, 263,000 measurements? All the data, underlying data?
Oh yeah.
Okay. Thanks.
Yeah, and all the background data, all the metadata, and if you have any questions, Danielle and I are, unfortunately, our names are on there too.
The question.
Oh, yeah.
The research that you talked about being done out Seattle Fisheries Lab, they indicated that the cause of these heart effects were due to alkylated pHs, particularly phenanthres, if I remember correctly. And I noticed that they showed now that they affect both salmon and herring. Question is there any way to take the data, all this huge data set, and look at the impact of these chemicals that are present in this system on the fact that the herring have not returned?
Ah, the herring question. We got Scott up next for that one. I mean, we do have all the chemical data to look at that. We have data not exactly from in the same way that they measure it in the lab. So they're able to take the water samples and take huge water samples and run them through and say this is what the fish were exposed to. We can do something similar with the passive sampler data, but we don't reach those levels. So but we do have data on alkylated phenandrines for sure. We got a lot of it. So we can definitely look at it, but unfortunately it's not exactly comparable to the lab study data. And that's a little bit of the challenge with environmental chemistry versus ecotoxicology. It's tough to get the same things at the same time, just because, you would get a snapshot of what's happening at the in Port Valdez, and maybe you should get that at the same time the herring are spawning. But a lot of the work that's been done on herring says that, yeah, they're affected by hydrocarbon exposure, but that doesn't explain the crash, and it doesn't explain the lack of recovery. And I think there's a lot of work that's out on that, or it doesn't explain their susceptibility to disease. And I think we talked about that in the committee meeting, right? But thank you. Good question. Yep, exactly.
Thanks for the presentation. Fairly simple question. A mussel exposed to hydrocarbons will quickly show that in its tissue. How long does it take that mussel to purge itself? And that ties in with, are the mussels that you're sampling outside the sound or in your control areas show any level of hydrocarbon whatsoever?
Okay, that sounds like maybe like 3 or 4 questions at the same time. I'll take the last one. Yes, we see hydrocarbons in essentially every sample that we run. They are incredibly ubiquitous in the environment, but I mean, they come from the sediments, they come from forest fires, they come from many, many different sources. And that's why it's so important that we use these forensic methods Unfortunately, the forensics methods don't work quite as well in blue mussels because they have their own thing going on. They are able to absorb specific kinds of hydrocarbons that the passive sampling device isn't as picky about. So they sort of do their own sorting and then they do their own level of excretion. So you don't see, you don't see many biomarkers in the mussels that would really allow you to indicate the source of the PAHs. If that was the sole purpose of the monitoring program, then I think we could make some changes to it so that that's possible, because I've seen it done in other studies, but it's not very easy to do at the moment. The other question was about how fast they get rid of them. So after the 2020 oil spill at the terminal, there was a lot of work done in LTEMP and I think LTEMP complementary projects to look at how fast those blue mussels are able to process that. And they were able to see a pretty steady decline over the course of months. But even a year later, the mussel concentrations were still elevated at the terminal. And then as far as what was happening in those mussels at that time, that's really well documented using the transcriptomics work, which is, what changes are happening in the gene and protein levels in these mussels, how much injury are they actually experiencing since they live next to a terminal. Like they that's where they live. So they have seen hydrocarbons before.
Yeah, we've got Ben Wilkins online, said, thanks, Morgan, phenomenal work. What's next for this project? Any talk about expanding or contracting monitoring?
I think the conversation is ongoing. Every time this work is presented, there's always questions about, hey, should we do this? Oh, should we cut this? But that's where it's really great to go back to what's the aim of this project and make sure that while the baseline data sometimes isn't very exciting, it's really critical to continue that work so that we can compare it to, a spill event that we wouldn't be able to predict. So I think maybe we were going to explore a little bit more of how to communicate these results better. That was one of the more recent discussions that we had. So not only posting the data set for nerds to use, but also maybe having some different interactive ways to view the data, what I think would be a really great tool so that people can see how the levels change over time, or look at a specific site and say, hey, is this, how are the mussels doing in the outer Zykov Bay versus the inner Zykov Bay station?